Hello, everybody. Today we're going to start chapter 3, and it begins, the whole chapter is on inequalities. Starts with linear inequalities in one variable, absolute values. We're going to do some two variable stuff as well, um, but we'll deal with inequalities and how to graph them in this lesson. So, we'll talk about linear inequalities in one variable, polynomial inequalities, two variables, and then polynomial in two variables. Okay, here we go. Linear inequalities in one variable. Now basically what we want to do with this is we want to be able to solve it and be able to graph it. Okay. Well, if I'm going to solve this, I'm going to solve this basically treating the inequality as an equal sign. So first thing I would do is add 5 to both sides. 2x is greater than 6, and now I divide by 2, so x is greater than 3. Now if I graph this, I'm going to mark 0, and then I'm going to go to 3, and it's an open circle at 3 because it's not equal to, it's just greater than. And since x is greater than 3, that means I'm going to go to the right. Okay, very simple. Now, let's go back to this step right here. Remember, if ever you divide by a negative, so if it was negative 2x is greater than 6, and you divide by negative 2, remember, you have to switch the inequality when you divide or multiply by a negative number. You have to switch the inequality if you divide or multiply by a negative number. Okay? All right, good enough. Let's move on to the next one. Now we've got an absolute value. Now, let's take a look at this. Here's how you do absolute values, a little reminder. You divide it up into 3 pieces. 3x minus 1 is less than 4, so the original piece. And 3x minus 1 is greater than negative 4. Okay? Little trick with inequalities. Because if I have the absolute value of x, that could be, the absolute value of x is greater than 6, we'll say. Okay? Well, let's say the absolute value of x equals 6. Well, that means x could be 6 or x could be negative 6, because when I take the absolute value of both of these numbers, I end up with positive 6. Okay, now why do I have to flip the inequality? Well, if the absolute value of x is less than 6, okay, so that means any value of x is less than positive 6. Well, that means that if x equals negative 6, like in this case, I can't be less than, because that would be like negative 7, negative 8, negative 9. Absolute value is not going to work, so I have to use greater than negative 6. So those would be my two equations. X is less than 6, x is greater than negative 6. That's the logic for why this happens. Now once you have that, now you just go ahead and solve like normal. So 3x is less than, so add 1 to both sides. 3x is less than 5. And now I divide by 3. So x is less than 5/3. Well, there's 1. Now I solve the other one. So 3x minus 1 greater than negative 4. So I add 1 to both sides. 3x is greater than negative 2. X is greater than negative 2/3. Now I didn't have to flip the inequality because I was dividing by positive 3. So it didn't matter. Now I graph it, so I mark 0. Okay, I got to go to 5/3, which is 1 2/3. Okay, so I'll make sure I note that. 5/3, it's an open circle. And x is less than that, so we're going this way. Okay, next is greater than negative 2/3. Okay, well that's obviously right here. And x is greater than that number. Open circle, because it's not equal to. And our answer is in between there. Okay? Take a look at the next one. Polynomial equation in one variable. Polynomial in one variable. Okay, well, interesting here. Interesting. If we're doing it in one variable, it'll make more sense if we do it in two, so we'll probably graph it in two here. But first thing I got to do is I got to factor this. Okay, so 2x and x. Okay. Let's see. It's going to be -1 and +1, because -1 times +2 is -2, and 1 times x is 1, so -1, or -2 plus 1 is -1. So we're good there. Now, this tells me where my zeros are at, correct? X is going to equal -1/2 if I solve this one, and x is going to equal 1 if I solve this one. Now, we know what this looks like. Okay, we've graphed enough quadratics at this point that we should know what this looks like. We've got a 0 at 1 and a 0 at -1/2. Okay, now, what way does this graph open? Well, it's going to do something like this. Okay, if we're just being real casual about it, it's going to look something like this. Okay, now, if I'm worried about the inequality, it wants to know when this equation is greater than or equal to 0. Okay? Now I'm graphing it in one variable. This graph here is in two variables because I've got an x and a y-axis. This is not the graph they're looking for. Okay? They're looking for a graph in one variable. So, but it's easier for me to see in two if I do it this way. Okay? So, here's what I'm going to do. I'm going to mark 0. Then I'm going to mark my zeros. Now here I'm going to have a closed dot because it's greater than or equal to. Now, this graph is greater than or equal to 0 here and here. That is where it's above the x-axis. So that means if I'm graphing it in one variable, it's this. It's going either direction because the only piece that is not positive, that is not above the x-axis, is this little dip down here. So that's the part that we're not worried about in here. Okay? Does that make sense? Hopefully. Hopefully. Okay? So that's graphing in two variables on a number line. We're just deciding where it's supposed to be. And this graph needs to be greater than 0, so where the graph is greater than 0 is where we graph. Again, this is the answer they're looking for. If you're graphing in one variable, it needs to be on a number line. Okay, here we go. Next one. Linear inequalities in two variables. Two variables, okay? This one might be the one you're a little more familiar with. Okay, we got a line here. Let's find our y-intercept, so let's let x equal 0. Okay, and let's find where we're going to cross the y-axis. So y equals 2. And now let's find the x-intercept. So 2x plus, I'm plugging in 0 for y equals 6. So x equals 3. There's my y-intercept. Now, is this a solid line or a dotted line? It's a solid line because it's equal to. So I have a line here. Solid line here. Now, this is where we do the shading, okay? Everything either above the line or below the line is going to be an answer. We're not sure which, okay? So how do we decide? Well, we pick a point that's obviously on one side of the line or the other. I like to pick 0, 0 when possible because it's easy to use. Because if I plug in 0, 0 in here, I'm going to get 0 plus 0 is less than or equal to 6. So 0 is less than or equal to 6. Is that true? Yes, it is. So since that's true, that means every other point below this line is true. If it would have been false, we would have shaded up here, but it wasn't, so we don't. Okay, we shade down here. And every answer, including that line, every answer below that line and including the line is an answer to the equation. Okay? Shading. Polynomial inequalities, okay? Same idea. Same idea. we want to graph the polynomial. We want to graph the polynomial, and then we want to figure out where we're going to shade. Nothing changes except now I'm just dealing with a quadratic or a cubic or whatever, and we know how to graph those now. So first thing I'm going to do is factor. So 3x and x, and it's going to end up being minus 1 to give me a negative 4 in there and a positive 1 on the outside. Okay, so I've got x equals 1/3 is 1, 0, and x equals positive 1 is another 0. So I'm at 1 and I am at 1/3. Okay, so something like this. It's a quadratic, so I know what it looks like. It's a parabola. It opens up. So it's going to do something like this. And again, this is a solid line because it's greater than or equal to. If it was just greater than, I would have a dotted line. Okay? Now I need to decide where to shade. Okay? Well, I need to pick a point that's obviously on one side of the line or the other. Now, I can get away with 0, 0 again here because obviously 0, 0 is on one side or the other. Okay? If you don't like 0, 0, you want to be safer, pick something out here. But pick something that's obviously on one side of the line or the other. Okay? We can get away with 0, 0. So that's what we're going to plug in is 0, 0. Okay, and if we plug in, we get 0 is greater than or equal to 3 times 0 squared minus 4 times 0 plus 1. So 0 is greater than or equal to 0 minus 0 plus 1. So 0 is greater than or equal to 1. Is that true? That is not true. So that means that this point here is not a solution. So that means my solution is inside the graph. Everything inside that graph, including the line, is a solution. Okay. Good stuff. Good stuff. So, linear inequalities, two variable inequalities with some quadratics. Basic idea, trying to decide where the solution's at. When you have an inequality, your solution set is much bigger. That's why we need to shade. Again, we'll review this again when you get back to class, and we'll go from there. So, we will see you in class.